All right, this is the last question that you've asked me. It's about chapter 17, problem 75, B and C. And this isn't the whole problem, but you're just specifically asking about one small part, so I'm just going to draw that part out. So your question was why in B, after we're adding this hydroxide and water, is there this methyl group here? Whereas when we're doing the same thing in C, there is not. And it's because the reactants are different here. So you can see in B we have a ketone, in C we have an aldehyde. And you just have to think about, in order to produce this product, you really just have to be able to visualize pretty quickly the mechanism and what's happening. And it takes practice, but let's just think about it. So this whole chapter, in chapter 16, we've been talking about a lot of reactions involving the alpha carbon. And so that's what's going to be happening here. This hydroxide base is going to deprotonate one of the alpha carbons, leaving electrons there. This carbon is a nucleophile. It's going to attack the carbon on carbon, swing those electrons up. And so what do we just do? I'm just going to redraw our ketone here that's attacking. I'll do 1, 2, 3 there. 1, 2, 3. And then let's just number this 1, 2, 3 as well. So what we're going to have is a bond between carbon 2 of the green, the ketone on the left, and carbon 2 of the ketone on the right. And so this is going to be this new bond right here. And what is this carbon 2 of the red ketone bonded to? It's bonded to a carbon. So let's just draw that out. A carbon, and also the oxygen, which after working up with water, will get the hydrogen there. And so mine's drawn a little bit different, but you can see these two are the exact same. And so that's why we have this methyl right here, is because of the reactant that we're starting with. Let's look at C. C, we're now starting with an aldehyde, but it's going to be the same thing that's happening. First, we'll have the base. There's only one alpha carbon here, right there. Since we have a hydrogen here, there's no carbon there. So there's only one alpha carbon. In this aldehyde, the hydroxide is going to pull off a hydrogen. The electrons are going to be left behind. Now this carbon is a nucleophile that can attack this electrophilic carbon on carbon. Electrons swing up. And then we just have to count all our carbons, make sure we've got them connected in the right spots. And so here, I'm just redrawing. We'll label it our ketone on the left, 1, 2. What's happening? We're going to have a new bond in between carbon 1 of this aldehyde here and carbon 2 of this aldehyde here. And that's it. Let's recount this, make sure we've got it right. This is the new bond that formed right there in between the alpha carbon of this aldehyde, which I've labeled 1, and the carbonyl carbon of this aldehyde, which I've labeled 2. And so just looking back over here on the left, this carbon 2 is bonded to what? Another carbon, a hydrogen, and an oxygen. Let's still make sure it's bonded to that. Another carbon, oxygen, and there's the hydrogen there that I just haven't drawn.